Like I said, it's on the Google class page. This is called Graphical Method Summary. Just kind of talks about what a graph shows us as far as information. And graphs are really useful for us because always in our class we're trying to analyze how one variable relates to another variable, or how blank affects blank, right? And so a graph is a very useful visual representation of how blank affects blank. That's why we use them so much. And it just kind of bridges the gap between data and getting an answer for your question of how something affects something else. So basically on this graph we have 4 columns. The first one is graph shape. The second is written relationship. Then modification required to linearize graph. This is why I'm showing you guys this today. And then the algebraic representation of the equation for the graph. Okay, so first two, obviously those are really easy to kind of understand how y affects x here. Here, y doesn't affect x, right? Because y is just always the same, and x can change, it doesn't affect it. Here, as as x increases, y increases proportionally, we could say, or it's directly related to x. The equation that goes along with that is the equation of a straight line. And then down here, these are the 3 things that you could memorize, but they're just different shapes of graphs that you get when you plot your data. They can tell you the written relationship, but the important part right here is this column right here, where we see how to modify your data to linearize your graph, or just look at the data in a different way, okay? So if you graph your data for this lab and you see something like this, to get that data to be a straight line, which you have to do, you're going to graph y versus 1 over x, or y versus x to the negative 1. When you do that, you'll get a graph that's a completely straight line, and I'll show you this in a second. And the equation for that new graph is y equals your slope of that new line times 1 over x, because you modified that variable, okay? You'll get the same thing if you modify this by graphing y versus x squared, and the same thing if you graph y squared versus x here, okay? So what we're going to have to do this unit is we're going to learn how to recognize these different graph shapes, how to make them straight lines, and then how to come up with an equation from that new straight line. Okay, that's kind of just an intro to what we're going to be doing. I'll probably have that as a part of our quiz. Sometime towards the end of the week, we'll probably take a quiz on linearization. Look at some data is what I wanted to do. So, okay? So you collect data on your buggy, data on whatever future experiment. Here's what it looks like. Okay, so step 1, you pull up that copy of the graphical method summary, okay, and you go, which one does that graph look like? And you say, I think it looks like the second one from the bottom. Okay, it curves upward like that. All right, so the important part of this is what to regraph, okay? So to linearize it, that means you're going to regraph some other data, or you're going to take your data, you're going to modify your data. Modification required to linearize the graph. We're going to graph y versus x squared, okay? So by hand, for this lab, you're going to take all of your horizontal values and you're going to square them and put them in that big data table that has 8 columns, okay? But here, we can just let the computer do it for us because computers are great, right? So we'll take the x values, right, and we're going to square it. So to do that, if you want to, do all this by computer, you could. You just need to make sure you include it in your lab write-up. If I click these 3 little dots here on the program Graphical Analysis by Vernier, you can add a calculated column, okay? You can name it whatever you want to. Let's just name it x square, because that's what we're doing here. We don't have any other information on it. We won't add any units because we don't have any information here on what this data actually is. And then you can insert any crazy redonkulous expression, but all the ones we care about are up top here. This is 1 over x, and this is x to the something, and we're going to make it to the 2, right, because we want to square it. We could click apply, okay? Didn't do anything yet, but you can Now tell the computer, I want you to graph what I just calculated, and y'all, swam out. Oh my gosh, what just happened, Mr. Carroll? You linearized the graph, because now that thing is straight up straight, okay? Linearization, you make it linear, okay? Now what we're going to do is write the equation. Here's what we did, just in summary real quick. Again, okay, we started off with data that looked like this. This was Y, this was X, right? That looks messy. This is X, okay? Then we regraphed it, Y versus X squared, and now we got that right there, right? Okay, this is a straight line. The equation, the general equation for a straight line is just y equals mx plus b, right? But here our x value isn't just x, it's x squared. So if we're going to write an equation for this, it would be y equals mx squared plus b, okay? When you get a graph in the lab, your y isn't going to be a y, it's going to be an x. Your x is going to be a t squared. And then your slope and your y-intercept you need to include from your data, okay? It guides you through those steps. Any questions about linearization?